Whether you're sipping your morning coffee or catching up later, we've got your industry insights. Welcome to Auto Intelligence, where we explore the intersection of automotive, artificial intelligence, and mobility innovation.
I'm Claire, and I'm here with Steve, and we're both part of the Auto Agentic team. New episodes drop every Tuesday, Thursday, and Saturday. And today we're diving deep into something that will fundamentally change how you think about transportation forever.
That's right, Claire. We want to thank our growing audience for tuning in. Your engagement and feedback continue to drive these conversations forward. Today, we're not just exploring mobility innovation, we're witnessing the birth of an entirely new category of machines that blur the line between vehicle, robot, and intelligent partner.
Picture this. A viral video shows what appears to be a rideable robotic horse galloping through forests, military robots that can navigate combat zones autonomously, underwater vessels that map the ocean floor without human crews, and humanoid robots that are already working alongside humans in warehouses. Some of these are real, some are aspirational, but all represent the future of mobility.
We're talking about Boston Dynamics' Spot robot, Hyundai's Walking Tiger concepts, Rio Tinto's fleet of autonomous mining trucks, and an entire ecosystem of mobility solutions that are redefining what it means to move through impossible environments.
Today's episode is Off the Grid, Into the Future, when mobility meets science fiction. We're going to take you on a journey through 6 revolutionary categories of mobility that are already changing industries from mining to military, from deep-sea exploration to space colonization.
Let's start with something that perfectly illustrates the challenge of separating fact from fiction in this space. Claire, you mentioned that viral video of a robotic horse. What's the real story there?
According to CNET's investigation, that mesmerizing video of a 4-legged robot galloping through forests with a rider on its back was actually a computer-generated concept video. It wasn't from any specific company's actual product, but rather a demonstration of what might be possible with current technology.
And that's exactly the kind of critical thinking our audience needs. The video went viral because it captured our imagination. The idea of a biomimetic robot that could carry humans through terrain no vehicle could navigate, but the reality is more nuanced.
What's fascinating is that while that specific video was CGI, the underlying technology it represents is very real. Boston Dynamics' Spot robot became commercially available in 2020 for $74,500 and can carry 14 kilograms of payload while navigating complex terrain.
Spot has been deployed in extreme temperature conditions, from Arctic expeditions to forest fire inspections. It can operate in environments that would be dangerous or impossible for human teams. So while we can't ride robot horses yet, we do have quadrupedal robots doing real work in extreme environments.
This brings up an important point about how we evaluate mobility innovations. The line between current capability and future possibility is often blurred in marketing materials and viral videos. Our job is to help you understand what's real, what's coming soon, and what's still aspirational.
And speaking of what's real, Hyundai's Tiger X1 concept represents a genuine engineering effort. This transforming intelligent ground excursion robot weighs 26 pounds and features 28 motors and sensors for omnidirectional movement.
The Tiger X1 can transition between rolling on wheels and walking on legs, and it's designed for disaster response, medical supply delivery, and even lunar exploration. It can be deployed via drones to inaccessible areas, making it perfect for search and rescue operations.
What's particularly interesting for our automotive audience is how companies like Hyundai are leveraging their existing expertise in completely new ways. They're using generative design and carbon fiber additive manufacturing to create lightweight but incredibly strong structures.
Now let's talk about where autonomous off-road mobility is already generating massive economic returns: the mining industry. Steve, the scale of what's happening in places like Australia is remarkable.
It really is. Rio Tinto operates approximately 190 autonomous haul trucks in Australia's Pilbara region, and they're achieving significant productivity improvements through 24/7 operation. These aren't small vehicles. We're talking about trucks that carry hundreds of tons of material.
Each autonomous truck operates, on average, an additional 700 to 1,000 hours per year and at a 15% lower cost than conventional trucks. That's not just efficiency. That's a fundamental transformation of how mining operations work.
Komatsu's autonomous trolley-assisted electric trucks represent another breakthrough. These systems combine overhead line power with battery storage, significantly reducing diesel dependency while maintaining their 363-ton payload capacity.
What's fascinating is how these systems handle the unpredictability of off-road environments. Unlike city streets with lane markers and traffic lights, these vehicles are navigating through dust storms, around massive excavators, and over terrain that changes daily as mining operations progress.
The technology stack is impressive. These trucks use LiDAR, radar, GPS, and inertial measurement systems to create real-time 3D maps of their environment. They're constantly communicating with central control systems and other vehicles to coordinate movements and avoid collisions.
Epiroc's autonomous loaders can now classify materials in real time, distinguishing between different types of ore and waste rock. This means they're not just moving material, they're making intelligent decisions about what to move and where.
And the safety benefits are substantial. Mining operations using autonomous trucks report significant reductions in accidents and injuries, particularly in hazardous areas where human operators would be at risk.
Now let's talk about something that's reshaping modern warfare: autonomous military vehicles. Steve, the developments in this space are both impressive and sobering.
They really are, Claire. Milrem Robotics TheMIS Combat UGV has been upgraded with advanced weapon systems featuring AI-assisted target recognition that reduces operator cognitive load during operations.
Field tests have demonstrated autonomous convoy capabilities, with multiple TheMIS units maintaining formation and coordinating movements over mixed terrain. This isn't just remote control. These systems are making real-time decisions about formation, speed, and route optimization.
The Ghost Robotics Vision 60 quadruped is being tested by military forces for reconnaissance missions. Its ability to navigate complex terrain while carrying sensor packages makes it valuable for situations where wheeled or tracked vehicles can't operate effectively.
What's particularly interesting is the amphibious capabilities being developed. Spain's military is testing the Valkyrie UGV, which can transition from sea to land autonomously, conducting littoral zone reconnaissance with significant payload capacity.
These systems are also being used for logistics. The ability to resupply forward positions without risking human lives is transforming military operations. Some of these platforms can operate for extended periods without human intervention, using efficient power management and solar charging.
But there are serious ethical considerations here. The integration of AI with military systems raises questions about autonomous decision-making in combat situations. The military is being very careful about maintaining human oversight in critical decisions.
Let's push the boundaries even further and talk about mobility in the most extreme environments imaginable, other worlds. Claire, NASA's approach to planetary exploration continues to evolve.
It really does. While NASA had to cancel the Viper lunar rover project in July 2024 due to budget constraints, they're repurposing its ice-detecting spectrometers and drill systems for future missions.
But the real game changer is NASA's Dragonfly mission to Saturn's moon Titan. This isn't a rover. It's a nuclear-powered rotorcraft that will fly between landing sites on Titan's surface. The launch is scheduled for July 2028 with arrival at Titan in 2035.
The engineering challenges are mind-boggling. Dragonfly's rotors have to operate in extremely cold conditions, powered by an isotope thermoelectric generator. It will be able to fly for about 30 minutes at a time, hopping between promising locations to analyze the chemistry of this mysterious moon.
JunoCam recently spotted a new volcano on Jupiter's moon Io, capturing sulfur plumes and lava flows at high resolution. These observations are helping engineers design future mobility systems for volcanic environments.
For terrestrial applications, NASA's Volcanobot 2 descended 82 feet into Kilauea's fissures, mapping magma pathways using obstacle avoidance algorithms. This technology could be crucial for monitoring volcanic activity and predicting eruptions.
What's particularly interesting is how space exploration is driving innovation in Earth-based mobility. The same technologies that enable a rover to navigate Mars' rocky terrain are being adapted for disaster response robots that can search through earthquake rubble.
Now let's talk about something that's happening right now in warehouses and factories around the world: humanoid robots that are actually working alongside human employees. Steve, this isn't science fiction anymore.
It really isn't, Claire. Agility Robotics has been developing their Digit robot for warehouse applications. While specific deployment numbers vary, The company has been conducting pilot programs with major logistics companies to test humanoid robots in real-world environments.
What's remarkable about these systems is their ability to work safely alongside human employees. Advanced collision avoidance systems and sophisticated sensors allow these robots to operate in shared workspaces without protective barriers.
Tesla's Optimus robot represents another approach to humanoid robotics. While still in development, Tesla has demonstrated prototypes performing various tasks, from simple object manipulation to more complex assembly operations.
The applications are expanding beyond just moving objects. These robots are being designed to learn from human demonstrations, adapt to new tasks, and even suggest process improvements based on their observations.
But it's not just about replacing human workers. Companies are finding that the most effective deployments involve human-robot teams. The robots handle the heavy lifting and repetitive tasks, while humans focus on problem-solving and quality control.
Let's shift gears and talk about how these technologies are transforming two of humanity's oldest industries, agriculture and construction. Steve, the changes here are remarkable.
They really are. John Deere has been a pioneer in autonomous agricultural equipment. Their autonomous tractors can operate 24/7 using GPS guidance and advanced sensors to plant, cultivate, and harvest crops with minimal human intervention.
What's impressive is the precision these systems achieve. GPS-guided tractors can maintain accuracy within centimeters, reducing overlap and waste while optimizing seed placement and fertilizer application.
In construction, companies like Caterpillar and Volvo are developing autonomous equipment for earth moving and material handling. These systems can work in dangerous environments like mines and construction sites while maintaining high levels of safety and efficiency.
The economic impact is significant. These systems can operate continuously without breaks, dramatically increasing productivity while reducing labor costs. But they're also creating new types of jobs: robot operators, maintenance technicians, and system supervisors.
And the environmental benefits are substantial. Precision agriculture reduces fertilizer and pesticide use, while autonomous construction equipment optimizes fuel consumption and reduces emissions through efficient operation patterns.
Before we wrap up, let's dive into another extreme environment that's pushing mobility innovation: the deep ocean. Steve, the challenges here are just as daunting as space exploration.
Absolutely. The 2023 EV Nautilus expedition used autonomous underwater vehicles to map 15,000 square kilometers of unexplored Pacific seafloor. These hybrid ROV, AUV systems can conduct biological sampling at extreme depths while dealing with crushing pressure and complete darkness.
NOAA's Ocean Exploration Cooperative Institute is using machine learning to classify species in real time, accelerating marine biology research through automated identification systems.
Ocean Infinity has been expanding their fleet of autonomous vessels for seabed mapping and exploration. These platforms can conduct surveys at extreme depths with high resolution, supporting offshore energy development and scientific research.
The USCG Polar Star's 2025 Antarctic deployment featured AI-driven route optimization that reduced fuel consumption by 22% during its 128-day mission. They're using advanced sonar systems to map underwater terrain beneath ice sheets.
These underwater and polar technologies are finding applications in other industries too. The same pressure-resistant systems used in deep-sea exploration are being adapted for underground mining operations and infrastructure inspection. You're listening to Auto Intelligence, brought to you by AutoAgentic,
the platform transforming automotive retail with intelligent, human-centered AI. Just like the mobility innovations we're discussing today, Autoagentic is reimagining what's possible when you combine cutting-edge technology with practical, real-world applications. Whether it's an autonomous mining truck optimizing its route in real time or an AI system optimizing your dealership operations, the future belongs to those who can seamlessly integrate advanced technology with human expertise.
What sets Autoagentic apart is our understanding that the most successful AI implementations aren't about replacing humans. They're about augmenting human capabilities. Just like the human-robot teams we've discussed today, our platform works alongside your dealership staff to enhance performance and decision-making.
Now, back to our exploration of revolutionary mobility innovation. Steve, there's a common thread running through all these innovations that directly connects to what we do at Autoagentic: the role of artificial intelligence in making impossible mobility possible.
Exactly. Whether it's Spot's terrain navigation algorithms or Tiger's AI-driven locomotion selection, these systems are only possible because of sophisticated AI decision-making that can adapt to unpredictable environments in real time.
The parallel to automotive retail is fascinating. Just as these mobility platforms need to adapt to changing terrain and conditions, dealerships need AI systems that can adapt to changing customer behaviors, market conditions, and inventory challenges.
Rio Tinto's autonomous mining trucks use sensors and AI to detect equipment status, weather patterns, and operational priorities, making real-time decisions about routes, speeds, and maintenance schedules. Similarly, AutoAgentic's platform uses real-time data to adjust sales strategies and customer engagement.
And just like Hyundai's modular approach allows different configurations for various tasks, AutoAgentic's modular agent system lets dealerships customize their AI implementation based on specific needs, whether that's inventory optimization, service scheduling, or customer relationship management.
The key insight here is that both extreme mobility and automotive retail require AI systems that can think strategically, not just execute predetermined tasks. These aren't just automated systems. They're intelligent partners that enhance human capabilities.
What we're seeing across all these mobility innovations is the emergence of what we might call collaborative intelligence, AI systems that don't just follow commands, but actively participate in problem-solving and decision-making.
Claire, we've covered the technical aspects of these innovations, but let's talk about their broader impact. These technologies are reshaping entire industries and creating new economic opportunities.
Absolutely. The autonomous mining sector alone is generating billions in value through improved safety, efficiency, and operational time. But it's not just about cost savings. These technologies are enabling operations in previously impossible locations.
Take deep-sea exploration, for example. Autonomous underwater vehicles are making it economically viable to conduct research and resource exploration at depths that would be prohibitively expensive with crewed vessels.
But there are also significant workforce implications. While these technologies are eliminating some traditional jobs, they're creating new categories of employment. Robot technicians, AI system supervisors, and remote operators are becoming essential roles across industries.
The key is ensuring that workers have the opportunity to transition into these new roles. Companies like John Deere and Rio Tinto are investing heavily in retraining programs, helping equipment operators become autonomous system supervisors.
There's also a democratization effect happening. Smaller operations that couldn't afford large crews can now compete with industrial-scale operations using autonomous equipment. This is particularly evident in agriculture, where family farms can access the same precision technology as large agribusiness.
And the safety benefits are enormous. Mining operations using autonomous trucks report significant reductions in accidents and injuries. Construction sites using autonomous equipment with proximity sensors show similar safety improvements.
As we look toward the next decade, Steve, what trends do you see shaping the future of mobility?
I think we're going to see three major convergences. First, the integration of different mobility modes into unified platforms. We're already seeing this with systems that can transition between walking, rolling, and even swimming depending on the terrain and mission requirements.
That's already happening with some military and exploration platforms. The next generation of reconnaissance and research vehicles will be truly multimodal, able to adapt their locomotion method to the environment.
Second, I think we'll see the emergence of swarm intelligence, multiple autonomous vehicles working together as a coordinated unit. We're already seeing this with mining trucks, but imagine construction sites where dozens of autonomous machines coordinate their activities in real time.
And third, the human-machine interface is going to become much more intuitive. We're moving beyond traditional controls toward more natural interaction methods, including gesture recognition and even brain-computer interfaces for specialized applications.
The implications for the automotive industry are profound. Traditional vehicle categories are becoming less relevant. The future belongs to companies that can think beyond cars, trucks, and motorcycles to create mobility solutions for any environment or challenge.
We're also going to see the rise of mobility as a service in extreme environments. Instead of owning specialized equipment, companies will access fleets of autonomous vehicles on demand, optimized for specific tasks and conditions.
And sustainability will be a major driver. Electric autonomous systems, hydrogen-powered platforms, and solar-powered underwater vehicles are showing how mobility can become carbon neutral or even carbon negative.
As we wrap up today's comprehensive exploration of off-road mobility innovation, it's clear that we're witnessing a fundamental transformation in how we think about transportation and movement.
From viral videos that capture our imagination to real autonomous mining trucks operating in Australia's outback, from nuclear-powered rotorcraft preparing to explore Titan to humanoid robots working in warehouses, we're seeing mobility solutions that were pure science fiction just a decade ago.
The implications for the automotive industry are profound. Traditional boundaries between vehicles, robots, and AI systems are dissolving. Companies that can successfully integrate these technologies, like the partnerships we're seeing between automotive manufacturers and robotics companies or construction equipment makers and AI developers, will define the future of mobility.
But perhaps most importantly, these innovations remind us that the future of transportation isn't just about making cars smarter or more efficient. It's about reimagining what mobility itself can be when we're no longer constrained by roads, wheels, or even gravity.
For automotive leaders, the question isn't whether these technologies will impact your business. It's how quickly you can adapt to a world where mobility means something completely different than it did even 5 years ago. The convergence of AI, robotics, and advanced materials is creating opportunities that didn't exist before.
The companies winning in this new landscape are those that understand mobility as a platform for solving human problems, not just moving people from point A to point B. Whether that's enabling safer mining operations through autonomous trucks, conducting scientific research in impossible environments, or augmenting human capabilities through intelligent systems, the future belongs to those who can think beyond traditional transportation categories.
We're also seeing the emergence of new business models. Mobility as a service is expanding beyond urban transportation to include specialized equipment for extreme environments. Companies are moving from selling vehicles to providing comprehensive mobility solutions.
And the pace of innovation is accelerating. The technologies we've discussed today will seem primitive compared to what's coming in the next 5 years. We're entering an era where the only limit to mobility is our imagination and our commitment to safety and ethical development.
This episode was produced by the team at AutoAgentic. Learn more at autoagentic.ai. AutoAgentic is a pioneering AI-driven platform transforming the automotive retail industry with intelligent, adaptive solutions designed to help dealerships streamline operations, optimize sales performance, and elevate the customer experience. What truly sets us apart is our human-centered, consultative approach. We're the most human AI company in automotive retail, delivering not just technology, but trusted guidance for navigating an industry in transformation. Thanks for joining us on this journey into the future of mobility. Whether you're sipping your morning coffee or planning your next innovation strategy, remember that the most exciting developments in transportation are happening off the beaten path, literally.
Until next time, keep exploring the impossible. And remember, in a world where the line between reality and science fiction continues to blur, the key is understanding what's real today, what's coming tomorrow, and what's still just a compelling vision.
Until next time, keep exploring the impossible.